Hello my dear students, let us solve one more example that is on strap footing. Proportion a strap footing for the following data. Allowable pressures that is 150 kilonewton per meter square for dead load plus reduced live load and 225 kilonewton per meter square for dead load plus live load. Okay, so the dead load for the column A is 500 kilonewton and column B is 600 kilonewton. Live load for column A is 450 kilonewton and column B is 800 kilonewton. Proportion the footing for uniform pressure under dead load plus reduced live load. Okay, distance of center to center of the column is 5.4 meter. Projection beyond column A not to exceed 0.5 meter. Okay, so here you have to design the footing for a uniform pressure under dead load plus reduced live load. Means you have to consider both dead load as well as the live load, reduced live load. So means you can consider 50% of the live load. It is asked to find dead load plus reduced live load. Okay, now center to center, that is given the distance that is equal to 5.4 meter. Center to center, that is 5.4 meter. This is column 1. The load is acting P1 and this is P2. The distance between P1 to P2 is capital L, and here the distance from here to here, that is the end of the footing, that is L1. Okay, and this is C1 divided by 2 because full is C1, this is full C2, so C1 divided by 2 is this portion, and eccentricity E is from here to here. Okay, so that is now R1, this is R2 and this is L dash. How to calculate here? See, first you have to calculate for find column A. What is the load acting on column A? How you have to consider dead load plus reduced live load. That condition is given here in the problem itself. So you have to find for pressure under dead load plus reduced live load. Okay, so that's why dead load for the column A, that is what dead load is, column A is 500 and reduced live load, that is 50% of the live load, that is 0.5 of 450. Okay, 0.5 of 450 equal to 725 kilonewton. This is the load acting on the column 1. Next, for column B, same condition, dead load plus reduced live load. Here dead load is 600 and live load, that is 50% of the live load, that is 0.5 of 800. Okay, so 600 plus 0.5 of 800, so equal to 1000 kilonewton. So P2 is equal to 1000 kilonewton. Now we have this equation. These equations I have given while explaining the strap footing. So R1 is equal to P1L divided by L dash. So R1 plus R2 is equal to P1 plus P2 and L1 is equal to 2 into E plus C1 divided by 2 and B is equal to R1 divided by L1 into QS. So all these formulas you have to remember. This is a standard formula. There is no change in the formula here. Here now C1 by 2 we required for to find L1. C1 by 2, that is given 0.5 meter. See here, this one, projection beyond column A not to exceed 0.5. So you have to consider C1 by 2 is equal to 0.5 meter. Now L is equal to 5.4 meter. That is also given here. L is distance of center to center of the column, that is this L. L is equal to 5.4. That is also given. QS is equal to 150. Okay, now we are calculating for 150. Let us see for take 150. QS is equal to 150. Now what you have to do? You have to assume one E value, eccentricity value. How you can take? Let us consider E is equal to 0.5 meter. Okay, substitute in this equation what it becomes? L1 is equal to 2 into E is 0.5 plus C1 by 2. C1 by 2 is 0.5. So you get L1 is equal to 2 meter. What is L dash? L dash is equal to L minus E. That is equal to, L dash is equal to L minus E. Here. This is L dash. So, okay. This is L dash. What is L dash? That is L minus E. Okay. Now, L is 5.4. Okay. L is 5.4. That is given. L is 5.4 minus E. E is 0.5 assumed. So it becomes L dash is equal to 4.9 meter. Now calculate what is R1. R1 is equal to P1L divided by L dash. What is P1? P1 is 725 into L. What is L? L is equal to 5.4 divided by L dash. It is equal to 4.9. So you get R1 is equal to 799 kilonewton. Now let us find what is B. B is equal to R1 divided by L1 into QS. So R1 is equal to 799 divided by L1. L1 is 2 into 150. L1 is 2 here. Into QS, allowable pressure 150. So you get B is equal to 2.66 meter. Now calculate what is L2. L2 is equal to P2 divided by B into QS. Okay. So what is P2? That is 100. Okay. So 1000 divided by B is 2.66 into QS, that is 150. So you get 2.506. Okay. So like this you can calculate what is L dash, what is R1, what is B and what is L2. Okay. Once if you get that, you can now calculate what is R1. How you can calculate? Now we have L1, L2, L dash and B are known corresponding to the value of E. Now R1 is equal to P1L divided by L dash. Correct? P1L divided by L dash. So P1 is 725 into L. L is 5.4 divided by L dash equal to 799 kilonewton. R2 that is equal to P1 plus P2 minus R1 that is equal to 725 P1 plus P2 is 1000 minus R1 799 that is equal to 926 kilonewton. Now find what is QS1. What is QS1? R1 divided by L1 into B. This is why QS1 means based on this equation. Okay. B is equal to R1 divided by L1 into QS. So QS is equal to the same R1 divided by L1 into B1. Okay, or B. So substitute R1 is equal to 799 divided by L1. L1 is equal to 2 into B is 2.6. So equal to 153.6. This is greater than 150. What we have given value is 150 kilonewton per meter square. Now find QS2, that is R2 divided by L2 into B. R2 is 926 divided by L2. L2 is 2.5. Okay, this calculated here. L2 is 2.5 into B is 2.66. Okay, so what you will get? 138.9. So that is less than 150. However, QS1 is greater than QS, L1 has to be increased. So this is not safe because you are getting more than this value. Whatever the answer got, it's 153. It is more than 150. So you cannot consider. L1 has to be increased. Thus, this can be done by increasing the value of E. This is the first trial. So again, you have to change the E value and do the same process what you have done in the first trial. Now let us take the value of E is equal to 0.6 meter. So same method, L1. First you have to calculate L1. What is L1? L1 is equal to this formula, 2 into E plus C1 divided by 2. So what is that? 2 into, this is given value, C1 by 2 is 0.5 plus E. E is 0.6. So equal to 2.2 meter. So L dash is equal to L minus 0.6. Okay. So that is 5.4 minus 0.6 equal to 4.8. R1. You calculate again, use the same formula. P1 L divided by L dash. P1 is 725 into L. L is 5.4 divided by L dash, that is 4.8. You get 815.6 kilonewton. Again calculate what is B. B is equal to now R1 divided by L1 into QS. So R1 is 815.6 divided by L1. L1 is 2.2 into QS is 150, given value equal to 2.47. So B is equal to, now you can round it to 2.5 meter. Calculate what is L2. L2 is P2 divided by B into QS. P2 is 1000 divided by 2.5. B is 2.5 into QS 150. So you get L2 is equal to 2.67 meter. You can make it 2.7 meter. Again do the same process. R1 is equal to P1L divided by L dash. That is equal to 725 into 5.4 divided by 4.8. So you get 815.6. So R2 is equal to P1 plus P2 minus R1. So that is 725 plus 1000 minus 815.6. You get 909.4 kilonewton. Again cross check. QS1, that is equal to 815.6 divided by 2.2 into 250. That is this formula. Okay. QS1, R1 divided by L1 into B. So you get 148.29, that is less than 150. Now QS2. QS2 is what? R2 divided by L2 into B. R2 is 909.4 divided by, this is L2 into B. L2 is 2.7 into B. B is 2.5. So what you get? 134.7, which is less than 150. Now both the values are less than the given pressure. This is 148.29, this is 134.7. So it is safe. So what you can consider now, B is equal to 2.5 meter, L1 is equal to 2.2 meter and L2 is equal to 2.7 meter. This is the way to find or calculate the proportion of a strap footing. Mainly you have to find what is B, what is L1 and what is L2. Okay, so mainly what you have to do, this is the standard figure, like this only. Load is acting here, P1, P2, this is C1, C2, R1, R2, and this is C1 by 2. Here this is C1, C2 by 2. Here you can consider eccentricity here also, no problem. In this problem it is considered eccentricity here. So L is this one, L dash is L minus E. Okay, then use all these formulas R1, R1 plus R2, L1, V, everything. Next, consider what is eccentricity. Assume, find the dimensions and check the allowable pressure. Both the pressure should be less than the given value. Then only that value you can consider. I hope all of you understood. Thank you.